Today's topic is molarity. Molarity measures the concentration of a solution, and there's a nice formula we can use for this if we choose molarity equals moles of solute over liters of solution. And as you can see, if you take a look at the picture down in the bottom left-hand corner, we have a solution that has a large number of solute particles dissolved in it. And we call that the more concentrated solution. And you can see then to the right of that, we have what we call a more dilute solution, where we don't have as many solute particles dissolved in the same volume of solution. But again, concentration is comparative. Whether something's dilute or more concentrated, you kind of have to compare them to each other. The calculation part, let's see how you do. So this is a good place to pause the video, try solving these two problems, and we'll see how you do. So for this first problem, hopefully you came up with 4.74 molar solution. Again, molarity is equal to moles of solute. In this case, our solute is salt or sodium chloride, 0.450 moles. And then our volume is 95 milliliters. Now remember that we have to have the volume in liters. So we're going to go ahead and we're going to convert this to liters. So 0.0950 liters. And that's what's going to go on the bottom, 0.0950 liters. Thinking about significant figures, by the way, both of these measurements have 3 sig figs. And so my final answer should have 3 significant figures. Now for the problem on the bottom, we could really use the formula molarity equals moles of solute per liter of solution. And so if you wanted to, you can convert this to moles of sodium chloride and then just divide it by the 0.0750 liters of solution. I'm going to do this a little bit different. I'm going to use my conversion factors and my units to kind of work my way through. So I know that I've got 15.0 grams of NaCl in a volume of 0.0750 liters. And then I'm going to go ahead and use the molar mass here to convert grams of sodium chloride to moles. And I know that I have 1 mole of NaCl for every approximately 58.44 grams of NaCl. So instead of doing this in 2 separate steps, I kind of just combine them together. But the main point, grams cancels, and I'm left with the units that I'm looking for molarity. And so hopefully you got around 3.42 molarity for the concentration of this solution. 2 more problems I want you to try. Take a minute, pause the video, see what you can come up with for these 2 questions. So for the first question, we get about 3.08 grams of calcium nitrate, CaNO3, 2. So knowing that molarity is really moles of solute per liter of solution, thinking about the fact that we want grams, I'm actually going to use molarity as a conversion factor. Now you could just plug it into the formula, and you have this formula, or at least a word version of it, on your equation sheet. But here's kind of what my process is going to look like. I'm going to take my 0.0750 liters of solution that I have, and I'm actually going to use molarity. Instead of using the capital M, I'm going to substitute in moles per liter, so that way I can get the units for liters to cancel. So 0.250 moles, and that's calcium nitrate, for every 1 liter of solution. And so that was really my first step, is to get rid of volume. Now I just have to use molar mass to get rid of moles. I know that 1 mole of calcium nitrate has a mass of approximately 164.1 grams of CaNO3, 2. And that way my moles has canceled out, and I'm left with the unit that I want. I just wanted to show you kind of a different way of solving this, rather than just plugging it into a formula, but to see kind of how those units can lead you to the correct unit that you're looking for. This last problem, here's what we come up with. And let's just kind of take a look at why we get the same concentration of calcium ions, but double the concentration of nitrate ions. So remember, you have a 0.25 molar concentration of calcium nitrate. So calcium nitrate is CaNO3 2. And the concentration again is 0.250 molar. When we dissolve this in water, we get calcium ions, but we get twice the number of nitrate ions. And that comes right from the formula right here, and that little subscript right there. And so when I'm looking at concentration, I see that I have a 1-to-1 ratio between my formula unit for calcium nitrate and the number of calcium ions. So that molarity is going to actually stay the same. That's going to give me a 0.250 molar for that particular ion. But I have double the amount of nitrate ions. So I'm going to double the concentration, 0.250 molar times 2. So that gives me a total of 0.500 molar for my nitrate. So in other words, every time one of these units disassociates, it disassociates into 1 unit of calcium ion. So the concentration of calcium ion is going to be the same as the original calcium nitrate, but double the concentration of nitrate ions. Something else that's kind of interesting is they could ask you, what is the total concentration of ions? And we can see if we look at a total concentration of ions, we basically have to add these together. So my total concentration would be, for every 1 unit of calcium nitrate, I get 3 units of ions. I get 1 calcium 2 plus and 2 nitrates. So that ends up being a total of 0.750 molar ions total. We make the solution in the first place. How do we get the concentration that we want? Well, the first thing that we have to do is we have to calculate how many grams of the solute we need to mass out. Since our balance doesn't record in moles, we need to go ahead and use molar mass and figure out what mass of the solute we need to measure out. So this particular example down here, we're using cobalt 2 chloride dihydrate, and you can see they've massed out about 10 grams of that particular compound. So that part we usually have to calculate to find out what mass we need of our solute. And then what they do is they put that in a volumetric flask. And you can see this volumetric flask is specifically graduated to 500 milliliters, which means it will appropriately make 500 milliliters of solution. And there are all different sizes of these volumetric flasks depending on how much solution you want to make. But in this case, they put the cobalt 2 chloride in the volumetric flask. And then their solvent actually in this example is ethanol. Now we'll usually use water, but ethanol works as a really good solvent for ionic compounds as well. And so they add some ethanol, they swirl it to dissolve it, and then they add more ethanol until they get to the graduated mark, which is that little mark that's on the flask, and the meniscus should sit right there. And then they invert it several times to mix. And that makes what I would call a stock solution of cobalt 2 chloride in whatever molarity you wanted to make it in.